Hello students, today we are going to see some more interesting and important questions from MS Chouhan sir's Organic Chemistry level 1 and the question from 131 to 140. Now these questions and all belongs to the concept of keto-enol tautomerism. Even last video we have gone through 121 to 130. Those questions also belongs to keto-enol tautomerism and we have learned many important concepts related questions we have seen. And the same with this also. Come on, let us discuss the first question. They have given the compounds in the correct stability order of the given tautomerism. Okay, so here generally as we observe, this is enol formation, this is keto formation, and again enol formation, but where it has attached, that is very important. Now in that keto form is more stable than enol form, you know very well, that is thermodynamically keto form is more stable than enol form. So the second one, it is greater, and then first one and third one, in that among I will give the priority for that first one. Why? This key enol can be more stable due to increased conjugation. Now that point, what it is, increased conjugation. So that lone pair of electrons transfer over here. Again, this one will transfer. So this is actually what it is. Conjugation, it will be increasing format, so automatically it will come as a first and the last priority. Now actually as we observe this side, this is sp3 hybridization, whereas this is sp2 hybridization. In that sp2 hybridization, bridgehead carbon, it is actually Brett's rule violation. Brett's rule violation, what it is actually, it is bridgehead carbon, that should not be the double bond. If a double bond comes, means it is highly unstable, highly unstable. So naturally, this one will come third. I hope you got the clarity. And one more way also we can bring it. This is the correct point. And one more also, I just to bring that same idea for you. C double bond O, that is carbonyl carbon, and C single bond C. This point, which is greater than C single bond O, C double bond C. So this carbonyl carbon, which is more greater than this kind of formation. Right. I hope you got the clarity. See, the questions may be vary in a different way they may ask, but the concept will be same. So always we catch hold of that concept and we can solve all the problems. Hope you got the clarity. Now, which is the correct option? Option C, second one and third. This is the correct formation. One more point also I would like to mention in this point, angle strain. When we are talking about angle strain, the second, this point, actually this is also sp3 and this is also sp3 and this is sp2. Come on, let us check in that second compound here, sp3, right? So sp3 means what it is, 109 degree, and this angle, it is 60 degree, right? So 60 degree, 109 minus 60 degree, what you will get it, 49 degree, right? Okay, now the second one, what it is, okay, now this is second one. Now first one, what it is, first one here I can show this first one, sp3. So first one sp3 means here actually sp3, first one it is sp3. So first one sp3 means 109 degree, and the third one, what it is here actually, third one 120 degree, right? So why it is 120 degree? Because of sp2 hybridization. So here third one, it is sp2 hybridization, so naturally 120 degree. So 120 degree, and that angle strain, it is 60. So it is 60, so automatically you will get 60 only. So which is the highest and which is the lowest, in that way we can identify, right? I hope you got the clarity. This is sp3 hybridization, though it is having what it is, enol formation. So enol formation, what I brought that point here actually, here continuous increased point of conjugation, so from here to transfer of electrons. So enol form, this also enol form, in that among which is highest. So this is sp3 and this is sp2. In that way I just to bring it second, this is the first one, and first it is the second one and third one. I hope you got the clarity in this point also. Generally as we look at that compound, enol form is more greater, in that way. Then the second one, increased form of conjugation, that is the second one. And in this is Brett's rule violation, so that is actually in the bridgehead carbon there is no double bond. If a double bond comes, means it is highly unstable. So in that easy way we can identify. I hope you got the clarity. Come on, let's go to the next question. The next question, the same idea, same concept only. The questions are very some. Come on. That in the second question, now which is that more stability they are asking? Here also the same idea. Keto form is more stable than enol form. So naturally our eyes will go and catch hold of that second compound. And Next, first and third, whom we will give more priority? Of course, our I will go and catch hold of here only. Why? Because there is what it is, alpha hydrogen is there. So here one alpha hydrogen, this point one alpha hydrogen is there, right? So that means, and here also double bond it is there, but here alpha hydrogen is there. But in that, this double bond which is attached to that bridgehead carbon double bond comes means it is highly unstable. That is Brett's rule, right? You know very well. So naturally, a third one, it is more stable than first one. So first one, it is highly unstable. Why it is unstable? Because double bond which is connected to the what it is, bridgehead carbon. So in that bridgehead carbon, bridgehead carbon of a double bond, it is highly unstable. That is Brett's rule. You know very well, right? Now, which is the correct option? Second, third, and first. Second, third, and first. Yes, option D is the correct option. Option D is the correct option. Hope you got the clarity. Come on, let's go to the next question. The next question here, the correct order of enol content XYZ. So keto form converted to enol form. Here, one more concept, I just bring it. So here, aromatic, it is greater than non-aromatic, it is greater than anti-aromatic. Okay, now here anti-aromatic, it is highly unstable. That you know very well. Come on, let us identify the correct order. Okay, now here what it is, first compound here alpha hydrogen is available, right? Now here in this point here it is alpha hydrogen is available. So when that alpha hydrogen is available, so transfer of electron takes place here, OH. So that is what here OH. I just bring it to your idea. So that means here 2 pi electrons will be available. So this side 2 pi electrons and cyclic ring, right? Cyclic ring. So 2 pi electrons and cyclic ring. Naturally, what it is? This is aromatic. Aromatic. So 2 pi electrons and cyclic ring. So that is aromatic. The second one, diagonally, carbonyl compound, it is available. So here one C double bond O, here C double bond O. So that means this is alpha hydrogen and this is also alpha hydrogen. So naturally, due to conjugation effect, so that you are getting what it is, double bond. So that means here 4 pi electrons. So 4 pi electrons and cyclic ring. So 4 pi electrons and cyclic ring. So you will get what it is here, anti-aromatic, right? Anti-aromatic. Right. Okay. Now the last one here, C double bond O, only one C double bond O it is there. Other than that, you're not having anything. So alpha hydrogen you can find over here as well as here. So here completely away from that alpha hydrogen. So that means this is sp3 hybridization. Now here what it is, you are getting double bond over here this side when it converted to enol form. So this is actually non-aromatic. So here actually non-aromatic. So what is the order here? Aromatic, it's greater than non-aromatic, it's greater than anti-aromatic, right? That's what I told. It is mainly concept. If we know the answer. So that means this is X and this is Z and this is Y. So X is greater than, Z is greater than Y. So which is the correct option? X is greater than, Z is greater than Y. So option D is the correct option. Hope you got the clarity about this question. Come on, let's go to the next question. Same concept, different question. Like isotope, same molecular formula, different structural formula, like that. Here same concept, different question. Here also we are talking about aromatic, non-aromatic, anti-aromatic. Okay, now aromatic, non-aromatic, anti-aromatic, how to identify? I'll give that simple trick for you. Now aromatic, as we are talking about aromatic here, aromatic means here first and foremost 4n plus 2 pi electrons, that it has to be. So that means how many electrons you can identify means here 2, 6, 10 and 14 and 18, like this it will go. So first one 2, that is 4n plus 2, 2 plus 4 6, 6 plus 4 10, 10 plus 4 14, 14 plus 4 18. In that way you please remember, so that is 4n plus 2 pi electrons, and the carbon it has to be sp2 carbon, right? Sp2 carbon hybridization. And next one, what it is, conjugation, planar, cyclic ring. These are all the fundamental idea about aromatic compounds. Whereas non-aromatic, just the opposite, right? Non-aromatic. Aromatic means here this is non-cyclic ring, non-conjugated, non-planar. In that way we can identify, right? Now here, for example, double bond, single bond, like if it comes means this double bond which will conjugate over here, but here there is no more chance of conjugation. So that means this is sp3 carbon. So sp3 carbon which is belongs to that category means this is non-aromatic. Right, now anti-aromatic, always aromatic and anti-aromatic only, there will be a, what it is, confusion. So this is easy to identify. So anti-aromatic, how to identify? So anti-aromatic, anti-aromatic, aromatic, this is very simple, just like 4n plus 2 pi electron, here 4n pi electrons, pi electrons, that's all. So here 4n plus 2 pi electrons, that is Huckel's rule. So this is also the same, but here 4n pi electrons. So how many electrons you can identify over here means, here what it is, 4, 8, 12, 16, and what it is, 20, in that way 4 plus, like 4 plus 4, in that way you can identify. So this is the way electrons will be there. So here now the same idea you can bring it to identify the compounds. Now in that anti-aromatic, how to identify? 4n pi electrons if it is there means that is anti-aromatic, that is sp3. Here also cyclic, planar, everything will be there, but here which is that majority to identify, here 4n pi electron. So 4n pi electron means 4, 8, 12, 16, but here 2, 6, 10, 14, 18. So you know the difference, easy to identify. Now conjugation idea and all, how do we identify? You know very well. Okay, now which is more stable? In that way aromatic, it is more stable. Now this is another idea I'm giving, right? So aromatic, it's greater than non-aromatic, non-aromatic, aromatic, and it's greater than anti-aromatic, aromatic. So aromatic, non-aromatic, anti-aromatic. So now anti-aromatic, it is highly unstable. Easily we can identify. Hope you got the clarity. Come on, let us identify. In this point, this idea will help you to identify the correct option. Now here, see, actually here in this point, here furon-like structure, no, so lone pair of electrons are available. Inside also it is there. Outside you don't need to consider, because inside the electrons only transfers that will help for the conjugation. Right. So this also it is what it is, conjugation. The same way here also. So how many pi electrons will be available? So in the X compound, you will get 6 pi electrons. 6 pi electrons, which is what it is, aromatic. So X compound, it is 6 electrons, whereas Y compound, here also furon-like structure. So this is what it is. Here also transfer of electrons, here, that's all. So here 4 electrons. So 4 pi electrons. So 4 pi electrons means this is what it is, anti-aromatic. I hope you got the clarity. How do we identify? So this is aromatic. X compound, it is aromatic. Then Y compound, it is anti-aromatic. Right, you got it clear? Now the last one, here there is no chance of conjugation, only what it is, here only one side. So that what you will get, this side or that side, anyway. So here they put it here, so OH. So and double bond, single bond. So this is sp3 hybridization completely. So naturally this is non-aromatic. Z compound, it is non-aromatic. I hope you got the clarity. Non-aromatic, how do I identify? It is a cyclic compound, but sp3 carbon, it is available. There is no sp2 carbon. Sp2 carbon, it has to continuous for the conjugation. Right. So here double bond, single bond, again single bond. So that means here double bond, single bond. So sp3 carbon is available. So 100% this is what it is, non-aromatic, aromatic. I hope you got the clarity. Now, which is that more stable? Already I mentioned aromatic, it's greater than, non-aromatic, it's greater than anti-aromatic. So it means X is greater than Z, Z is greater than Y. I hope you got the clarity about this question. Now, which is the correct option? X is greater than, Z is greater than Y. Yes, D option is correct option. I hope you got a clear idea about how to identify that aromatic, non-aromatic, anti-aromatic. With these tricks, easily you can identify. Yes, come on, let's go to the next question with this clarification. And among the given ketone, the one which does not enolize, which will enolize very fast and which is more stable, whichever is having adjacent carbon is having alpha hydrogen, which definitely will give enol form. Right. Now, according to this, here 2 hydrogen is available, alpha hydrogen. So alpha hydrogen is there means definitely it will give enol form. So you will get what it is, enolization. So here you will get what it is, OH. And the same way here alpha hydrogen is available. This is the first term. compound. Second compound, alpha hydrogen only here, but here there is no alpha hydrogen which is connected with CH3. So CH3 which is connected to this carbon, that will, we cannot consider that as alpha hydrogen. So only here, that means here this electron when transfers here, so that means here you will get the double bond. So when double bond comes over here, this will be more stable, and when the double bond comes over here which is connected with bridgehead carbon, this is unstable according to Bridge's rules violation, right? So that means this cannot. Okay, let us check it with third one. Now here alpha hydrogen, where is it? Alpha hydrogen, alpha hydrogen is here. So alpha hydrogen here means what it is. So this will transfer on automatically, carry over the conjugation. So what you will get it, oh great, our phenol will be there to comfort us, right? So this is phenol, so this is 100% phenol formation, so more stable, right? So this is also more stable, and this is also more stable. Why? The double bond comes over here only. So but the double bonds which is attached that bridgehead carbon, no, this is violation of Brett's rule, which is highly unstable. So definitely second form enolized does not stable. That means among the given ketone, the one which does not enolize means a second compound. Second compound, why it does not enolize? Because this is connected with the bridgehead carbon. That is the reason. Bridgehead carbon, it is unstable according to Brett's rule. I hope you got the clarity. Come on, let's go to the next question. Question. See, these questions and all help us to identify the correct concept and confidence also. See, again, we are getting the same kind of question, but same kind of question but different question, right? Come on, now this compound when it goes to enolize, that means H2O. So when it is H2O, here it is D2O, heavy water. This is H2O, and here D2O, it is heavy water. This is ordinary water, D2O. Now the product, it will be, see, this is a carbonyl compound, the next to that carbon which is having alpha hydrogen. So that means here CH2 will be there, no, one hydrogen which is replaced by CH3, the other hydrogen it is freehand. So this hydrogen can be replaced with D. That means D plus DO minus, that is H plus OH minus, wrong. In that way, D plus DO minus or OD minus, in that way also you can identify. So this hydrogen, this part, which is going to replace that D, which is replaced by D. So that means which is the correct option will be coming. Option A will not be the correct answer because it is away from that what it is, alpha hydrogen. But here D it's come here, so option B is a correct option. Okay, let us check that. See here alpha hydrogen will not come over here, here only. This is aldehyde group, it is a functional group only. So next to that functional group, adjacent carbon only is having alpha hydrogen, not this hydrogen, this what it is, D. Okay, now which is the, all of this will not be the correct answer. So option B is the correct option. I hope you got the clarity. How do we convert? Alpha hydrogen is there, that means it is having that eligibility to form enol, right? Okay, come on, let's go to the next question. This is a ester formation, of course, that is both are ester formation, but there are slight difference over here. See, this is a carbonyl carbon, see, double bond O keto form, here alpha hydrogen, here also alpha hydrogen. So any one side you will get what it is, double bond, right? That means 2 pi electrons. So here what it is, OH will be available. Right now here furon like structure, no, so that means here lone pair of electron inside. So inside lone pair of electron transfer, so automatically you will get OH a single bond here, so you will get the double bond. So this also will transfer, and here, so conjugation effect continues. So definitely this is 6 pi electrons. 6 pi electrons means 100% it is aromatic. So aromatic, it is most stable comparatively these two. So second one, it is most stable because 6 pi electrons are there, 6 pi electrons, right? Second one, it is 6 pi electrons due to that aromatic compound. Now first one, only 2 electrons are there. So first one, 2 electrons only it is available. So this is a second category. Okay, now second category, that is first one, first compound, right? Now third one, what it is, here lone pair of electrons are there. Here when it transfers, what happened here, single bond, here OH. So that means here you will get what it is, transfer. So 4 pi electrons. So 4 pi electrons means what it is, this is anti-aromatic, right? So that is 4 pi electron, 2 pi electron, 2 6 10, in that way aromatic compound. 4, next one 8, then next one 12. So these are all anti-aromatic. So that means third group, it is anti-aromatic. So I hope you got the clarity. So which is the correct option? Second one, 3. Second compound, it is most stable because it is 6 pi electrons are there, highly stable, and 2 pi electrons next stable one, and the least unstable, it is 4 pi electrons, it is highly unstable because it is anti-aromatic, right? I hope you got the clarity. Those ideas, previous question I have given that idea how to identify aromatic, non-aromatic, and anti-aromatic very clearly. Hope you got the clarity. Now which is the correct option? Second one 3 always always they are giving that option. So second one and third, right? Come on, let's go to the next question. The next question, as we are talking about the concept about aromatic, non-aromatic, anti-aromatic, and how many electrons is eligible for aromatic and non-aromatic and anti-aromatic. Here also the same idea, but there are something difference. This is seven-membered ring trifolium. Okay, now the second point, wherever next to that carbon, carbonyl carbon, wherever next to that carbon it is alpha hydrogen, that will provide that enol formation, right? So according to that, here alpha hydrogen is available. So in that way, here this is a alpha hydrogen. So alpha hydrogen which is transfers the electron, so it will get the enol formation. So that means here you will get the single double bond, right? So double bond comes over here, means what it is, 6 pi electron. So that means it will be aromatic form. Okay, right, come on, let us check other two, then finalize the answer. Now in this, where is that alpha hydrogen? So that means alpha hydrogen, it is acidic hydrogen, that will provide the enol formation. Now that means here it is alpha hydrogen, so that will transfer here single bond, and here what it is, OH, here double bond will be coming inside, right? Now third one, where do we identify the alpha hydrogen? So here alpha hydrogen, here also alpha hydrogen, right? Okay, so that means this will transfer that. So you will get the double bond over here, here single bond, here hydrogen, and the same way this will transfer here double bond, here single bond, here hydrogen. So that means here OH, here OH formation, here also OH formation, right? Okay, now OH only it is there. This will not be available because this is transverse, right? Okay, now here also the same. Here OH formation is there, but here first compound it is most stable. Why do we say first compound it is most stable? Here OH is available. The next to that adjacent carbon which is having oxygen. So oxygen and hydrogen showing that intramolecular hydrogen bond. What it is? Intramolecular molecular hydrogen bond, right? So that means this will be more stable, though it is having all these 3 or 6 pi electrons aromatic only, but in that amount which is more stable, means intramolecular hydrogen bond is available. How do we identify? This is carbonyl group oxygen and the enol form OH hydrogen. So these both are having that intramolecular hydrogen bond, so that is more stable. Then next, these two, in that which is most stable, second it is most stable than third. Why? Because here single bond, here double bond, right? Here this is double bond, single bond, double bond, the same way from here, double bond, single bond, double bond, single bond, double bond. But here this point it is sp3 hybridization. Sp3 hybridization, it is what it is, non-aromatic, right? So that means here, how do we identify it as a non-aromatic? But here conjugation it does not continue because this is sp3 hybridization. Here this conjugation transfer over here, this conjugation, this conjugation. So this point which is not what it is, continuous that conjugation. So that means this is sp3 hybridized carbon. So that means this is the least one. I hope you got the clarity. First one, second one, and third one. So option A is the correct option. I hope you got the clarity. Come on, let us go to the next question. Same kind of concept but different questions. This will help you to get the confidence in your concept, right? Whichever way they are asking question, your concept it is thorough, you are able to apply that way the concept according to that question, the answer will be in your hand, right? Come on, here also keto compound it is there, and enolization among the given compound, the correct order of enol content. Now where do we identify enol content in that each point? Where is that alpha hydrogen? So here is the alpha hydrogen we can identify, so it will transfer over here, so you will get OH, right? So that means here what it is, single bond, you will get single bond over here, and the same way here also, here alpha hydrogen is available, transfer of electron, so automatically what happened, OH formation, so here you will get the double bond. And the next one here, alpha hydrogen is here, right? The alpha hydrogen will come over here, right? So that means it transfer of electrons. Here what it is, OH. So that means here double bond. In that, now let us check. Now this is angle strain. Now here when we are talking about angle strain, this is 90 degree. See, 90 degree angle strain, like what it is, square nose, so that is 90 degree angle strain. Whereas here hexagon, it is 120 degree angle strain. So which is more stable? 120 is bigger or 90 is bigger? 100% 120 it is bigger. So that means the second compound, it is more stable than first one. First compound, it is 90 degree. Both are what it is, 2 pi electron, 2 pi electron. Of course, it is more stable, 100%. But here we are giving priority second compound. Why? Because it is a 120 degree angle strain, it will be more. And where we are talking about 90 degree, it is the next one. And the third one, what it is? Here, 4 pi electrons are there. 4 pi electrons here too, here too. So that means 4 pi electrons, it is anti-aromatic. So anti-aromatic means what it is? Highly unstable. This is unstable. Highly unstable. So that means this is third, right? See, if you are knowing the concept thoroughly, you are able to identify the answer. The answer is in your hand only. Right now, you see the concept what I have given, like aromatic, anti-aromatic, non-aromatic. See, how do we identify easy? I have given the tricks. So please check it once again so that it will be easy for you to understand. Right now, 213, always the same kind of thing it's coming, right? So 213, where it is 213, D is the correct option. I hope you got the clarity. Come on, let's go to the last question. Let's go to this question to identify which is the correct option. How many geometrical isomers are possible for the above compound? This is very simple. As we observe here, double bond, and here double bond, and here also double bond. So this is like this point which is identical part. Okay, so identical part means we can identify here cis and trans. So in this point here, see now in this point CH3 this side and the CH3 this side. So the same way here, what it is, hydrogen will be there in this side also, hydrogen will be available. So when we put crisscross, so we will get a cis and a trans formation. So that means this side two cis and trans, that means two isomers are possible. And the same way here, this point when we are talking about, this is actually GI, that is geometrical isomers, it shows. So in this point also, here also CH3 part, here also CH3 part. Suppose this part, when it turns over this side, so this is CH3 and this side CH3, so this side H, hydrogen. So that means, so here also two isomers are possible, that means cis and trans. So CH3 both are same side, CH3 opposite side, so that means trans. So 2 plus 2, so that means 4 isomers are possible, right? I hope you got the clarity. How do we identify geometrical isomers? You know how to identify. C double bond, C here A, suppose here B means here A, and then the side B means these both are same, right? So this means cis. Suppose this side B, A and B, so that means this is A, so this is trans. So in that way, we can identify cis and trans in the geometrical isomers, right? So the same idea, I just bring it over here. So both the side, what it is, cis, and both the side trans. So these two are identical. So in that way, we can bring two isomers, cis and trans. And the same idea, I just bring it here. So this line, which shows CH3. So this CH3 and this CH3 shows cis, and this CH3 just to the opposite, yellow color mark now. So opposite side CH3, it is trans. So this is these two plus this two, right? So 4 isomers. Hope you got the clarity now. Which is the correct option? Option B is the correct option. Hope you understand all these questions. In our next video, next point, what we are going to discuss, geometrical isomers. That is what 140th question. It is geometrical isomers. So upcoming videos, it is related to geometrical isomers video only. Hope you got the clarity, and thank you for your great support. Thank you for watching.